right, so hello everyone. I'm Jordan. I'm the director of the project division at ATS. Today I will be presenting alongside Nils from the company Phoenix Contact. Nils is a business development manager for wind power, and Ibtissam works at SAP, and she is solution advisor for digital supply chain. First, I will explain in few words what we are doing at ATS. So on the next slide, Philippe, please. At ATS, we have two main activities. First one is ATS Engineering. In this company, we offer design engineering, 3D modeling, on general installation, mechanical structure, piping structure, as well as all calculation and electricity drawings. The second activity is with ATS Connect, in which we offer digital services. It means that we support industrial companies to connect their assets to IT systems. Here, the aim is to collect all the data from the existing machine, equipment, asset, and then to analyze it using some IT solutions that we can use with SAP, for example, but you will see it in the demonstration of today. On the next slide, to give you a better understanding, we have a diagram that illustrates how we are working at ATS. Our goal is to support you during all your project life cycle, from the design phase to the operating phase. On the design phase, as you understood, it's more related to ATS engineering jobs, in which we will create the first 3D model, and we will prepare the digital twin, in fact, at this stage, because we will create the first data regarding your project. And then, once the equipment is on site, it could be a wind turbine on this example, it's the role of ATS Connect to support you to connect this equipment, to connect this wind turbine with some sensors. And with this kind of sensors, we will be able to analyze what happened real time on this kind of equipment. So we have a global end-to-end approach with capital project engineering management. You will see at the end that it's related to our demonstration then. So ATS engineering on the design phase, ATS Connect on the operating phase, and we merge the two at the end to collect some data using real equipment to improve the design and engineering of new equipment or existing one. That said, I will now introduce our story. On the next slide, Philippe, please. So this is the global story we will explain today. So imagine a large offshore wind farm with dozens of turbines using the power of the wind to create clean energy. In our story, we have multiple personas. Emma is the site manager. And as a site manager, she has an interface to see what happened real time on the wind farm. Philippe, if you can switch to the next slide, please. The next one, please. All right. So on this kind of dashboard, Emma has a lot of information regarding the wind farm, but she has one alert today. So one of the wind turbine suddenly stops. We don't know why, but Emma, the site manager, has the information. Now we will dive a bit with the next slide, Philippe, please. So we have the information that something happened on the wind turbine. We don't know what for the moment, but hopefully this wind turbine is equipped with a lot of sensors, and we will analyze what happened with John, our data analyst. With Nils, we will explain what is the job of John.
Yeah, so just telling you a little bit more about our blade monitoring system. That is, if the customer is lucky, he has already on his turbine, because we have globally quite a good footprint with 4,500 systems, and the sensor installed base is even 6 digits already, and this might be used from the customer to see what is going on his turbine. And if you now say, okay, what is this blade monitoring that we're talking about? It is, so we call it blade intelligence. That means we are one central PLC unit that is collecting all Phoenix Contact data from Phoenix contact sensors. That means we have one system detecting ice. Okay, might be not that important for offshore, and might be not that important here in France, but we have monitoring for structural health, for seeing the structural integrity and the health of the blade itself. We know the load and the load cycles of the blade or even the complete wind turbine over the time. And we have a sensor that is measuring lightning strike on the wind turbine. So we stuck with the idea of lightning. Back. So if you have then an operator, I know that the manufacturers always say nobody has issues with lightning. If there is any operator, he might say something different. So, okay, we see there is a wind farm. We have, it's severe to lightning, so might more likely in the south of France than maybe in the North Sea here and Germany. But anyhow, everywhere in the world where you have wind farms, you will have issues with lightning, more or less severe. So that means you have lightning strikes. Okay, actually they just look on the very top of the blade, not very structural, but you see every data that you have. So this is the system. We take a look into the system, see, okay, there was a lightning strike. We see blade 3 was struck by a lightning, and these are real data. So we have a test. There was a turbine in Croatia, not offshore, onshore, but it was struck by the lightning. And we now even see the blade was struck within 600 milliseconds, 5 times with one lightning. So from a severeness of 1.5 kiloamps up to 5 kiloamps, negative impulses, and you can even see how the lightning was behaving. Okay, it was struck by lightning, that was one thing. And we see, okay, the turbine was turning in that moment, and you might see burning marks afterwards. But then the next more important topic is we see the outcome of our structural health monitoring. So the structural health monitoring is using the vibration data and it's calculating the eigenfrequency of the blade, and therefore you really see how it is behaving and how the blades are differently behaving on these patterns from the anomalies. So you see here, everything is calculated, but then you see one blade, it's here, it's 3. You see the graphs, the vibration patterns, eigenfrequency patterns are shifting at that moment. So that means, at that moment, you will have a structural issue with that blade. So there is something broken that will get very severe and very costly if you have to repair it, if you wait longer. And this is a moment, so you reach a specific value, you will have an alarming that you send from the Phoenix contact system to an upper level system like here from ATS.
All right, so Philippe, if you can go to the next slide. So to summarize, we started with FEMA, the site manager, who detect an abnormal situation on one of the wind turbines. Then with John, using some sensors and data collection, we identify an unusual vibration pattern on the blade. And now, with Lisa, the dispatcher and the technician team, we will see how we will address this issue with some remote assistance and IT solution from SAP.
Thank you, Jordan. So it's okay for the sound? Everyone's hearing me well? Okay, perfect. So here what I want to tell you about is how in SAP we are going to use generative AI and some AI use cases in order to make the life of a dispatcher and of a maintenance technician more easier and more effective. So we selected here some use cases taken under consideration, of course, the analytics and the data that we have gathered with John. And what we are going to do is, for example, make the life of the dispatcher easier by using some prompt here, natural language, to filter through all the data that we have and pinpoint and find all the issues, for example, that we have here on our specific equipment. What we can do also to help the technician is to have visibility on the history and the context of this specific equipment. Using, again, GenAI, we will be able to find all the insights for this specific equipment, the checklist, the measurements, all what happened in this equipment, and we can leverage this Gen AI and machine learning data and give them to the technician directly. And of course, also, it will help us for the dispatcher to help him prepare his maintenance work. So here I have put this data to the technician, and the dispatcher here will also be able to ask the system using machine learning in order to assign to the correct technician at the correct time with the correct skills to the issue that we have here, the mechanical issue. So we can use some rules, we can use some machine learning, some algorithms in order to find the best matching technician on the field for this specific issue. Once this is done, the dispatcher will send the maintenance request to the technician, and here the technician will have all of his information. He will have his task lists, his smart forms, his checklists, all the instruction that he needs to do. In here, in this example, we can put some task lists, for example, on a video with step-by-step to help him go through all the steps that he needs to do in terms of maintenance. Of course, he has the visibility on all his tools. He has the visibility on all his spare parts, all of his smart forms, checklists, and he can put all of that information on his tablet. Even if he does not have always the connection, he has all the information that he needs to do his job. Once he's ready, he will travel and see the distance, of course. Here we also can use predictive routing in order to find the best route to the customer or to the wind turbine park. He will log on, of course, all of his expenses. So in here we will put distances. It can also be his work time efforts. It can be his consumption for materials. All of this he can log in directly in his application. He can also use, of course, here he can scan some QR code to find the specific equipment, and he can follow up on his task list here for all his instructions to find everything that he needs to do, add some verification dates, his signature, of course, and the step-by-step instructions. He can take pictures, of course. He can use his voice in order to log on his technical reports. So all of the information that he needs to do, he will be able to do them in his tablet. Okay? After that, once he has taken this beautiful picture, he will be able to annotate it also, add some information if needed, and he will generate his technical report, of course, with all the efforts, consumption, signature, etc. Let's say in this case, for example, that this technician has some issues in the blade, but he does not have the expertise to do them. And that's where we can have also some remote expertise technologies with our partner TeamViewer, who will be able, for example, to connect an expert remotely with another technician who is in the field, and where he can help him, for example, do his work on remotely. So, Philippe, if you can just go to the second video to showcase this use case for the remote, let's say here, and collaboration with an expert. So with his smart glass, or even with camera sharing, he can speak to an expert in distance, and he can help him do the maintenance instruction or a specific procedure where the technician, for example, does not have the expertise. He can take pictures, he can guide him through all what he needs to do, and afterwards he will be able also to generate and have the history of all of what happened on this specific case. So we can see that we can gather a lot of data from the field also, and the idea also is what we can do with this data. What we can do also is the feedback, close the loop with the feedback improvements on the blade.
Thank you, Ibtissam. So, Philippe, if you can go to the next slide. So, now you can go back to this one. I will summarize a bit. So, now we saw that with the real-time data collection, with Phoenix Contact, and the data also used during the repair phase with SAP, we have a global loop that, on the next slide, Philippe, we will analyze. So during the operating phase of the asset, we collected a lot of data from the sensors, from the maintenance experts, and all this data will be used in your digital twin to improve the next generation of wind turbine, but also the existing wind farm to anticipate some failures, as we had on this one, for example. So this approach is different as other companies because our aim is to work with all the stakeholders, the different intervention on the wind turbine, for example, to collect the data, to improve all the design phase also. So it's a global approach. And now we will conclude with a few words. Our story is finished now. So as a conclusion, with integrated data from Phoenix Contact, maintenance solution with SAP TeamViewer, we were able to solve an issue, minimizing the downtime, saving some cost also on this intervention. We improve the design and we enhance all the maintenance phase. Thank you for listening us today.
Where they can find us today, if they want to have more
if you want to have a full
conversation.
demonstration, we are on the booth F32. We have all the sensors that we equipped on the blade. Nils is the expert to give you more information on all the sensors. And we also have all SAP team to explain you how to use remote assistance with TeamViewer team that is here also today. So thanks a lot. And I hope you enjoy the story. Thank you.
Thank you.